All right, so we're going to continue with graph transformations, and we're going to use just a very general function here that's defined with 4 points, and the points are -3, 2, 0, 1, 1, -2, and 4, 3. And then here's a little graph of the function. Okay, now I'm going to define a new function, g of x, that's defined as f of x minus 2. So g of x, for each x, I find f of x and subtract 2. So here I get 2, f of x, 2 minus 2 is 0. F of x is 1, so minus 2 is minus 1. Minus 2 minus 2, 2 more is minus 4, and 3 minus 2 equals 1. Okay, so let's put, so we get the ordered pair -3, 0. So right here and right here, 0, minus 1. 1, minus 4, and 4, 1. So this is the x, and this is the g of x. So I come over here, I'm going to get a different color. Now let's plot each one of these points. So -3, 0, 0, minus 1, 1, minus 4, so there's 2, 3, 4, and 4, 1. And so this is my graph, g of x. And so each point here is moved down 2. So when I have f of x minus 2, it takes f of x and it goes down 2. Okay, let's talk about domain and range. So let's talk about domain and range of my original function. My x's are the domain, and they go from -3 to 4. And then the range, the largest y value is 3, and the smallest y value is -2. So my range is -2, 3. Now if I come over here and look, my domain has stayed the same. So when I do things vertically, the domain doesn't change. But my range, when I move every point up, every point went down. When I move every point down, I move the left endpoint down 2, and I move the right endpoint down 2. So that makes my range -4, 1 for my function g, which is defined as f minus 2. And so there's my domain and range. All right. So now let's look at g of x equals f of x plus 1. So here, so I know what f of x is for -3, 0, 1, and 4. So those are the values that can go in, that can go into this function right here, that can go into f. And so that is 2, 1, -2, 3. Okay, but what's going in, I need the x's. So what x should I choose so that x plus 1 is 3? Well, if I choose -4, -4 plus 1 is -3, and so that's what's going to go into the g of x, or into the, yeah, it's what goes into g, and then so 2 comes out. If I want 0 to come out of x plus 1, then what I need is to put in a -1. So if x is -1, -1 plus 1 is 0, and so f of 0 is 1. And so for each one of these x values, I subtract 1. And so my result is -4, 2, -1, 1, 0, -2, and 3, 3. So when I graph this, my original function was -3, 2, 0, 1, 1, -2, and 4, 3. Okay, so there's my graph of f of x. And now I'm going to change colors. I'm going to graph these points. So -4, 2, -1, 1, 0, -2, and 3, 3. Okay, and so each one of these points got moved over 1 to the right. So my original domain over here for f of x was, so my domain was -3 to 4. And I basically subtracted 1. So I had 3, -3, -1 is -4. So I take my domain, subtract 1 from each endpoint. So my new domain is -4, 3. My range stays the same because I have moved horizontally. So when I move horizontally, the domain changes and the range stays the same. Okay, the next one . G of x equals minus f of x. So if x is -3, 0, 1, 4, and f of x is 2, 1, -2, 3, g of x equals minus f of x. I'm going to take this value and multiply it by 2. So I get -2, -1, 2, -3. And so graphing 1, 2, 3, 1, 2, 0, 1, 1, -2, and 4, 3. Okay, so that's the original f of x. This new one, it has points -3, -2, 0, -1, 1, 2, and 4, -3. So when I graph, -3, -2, 0, -1, 1, 3, and 4, minus 3. And so this, what happens here, this flips over x-axis. And my range, so my domain stays the same because I'm not moving horizontally, but my range, which my original range was -2 to 3, and that was for f of x, and I multiply it by negative. I'm going to do the same thing to my range. So multiply each one by -1. And my new range for g of x is -3 to 2. So remember, the smaller number always has to go on the left. Okay. The next one. Now, we didn't get to see this in the previous example with the parabolas because it's an even function, but if it's not an even function, let's see what happens if I take when I take f of minus x. So minus x needs to be -3, 0, 1, 4. So what does x need to be so that when I multiply by a negative, I get -3? Well, that would be 3, 0, -1, -4. So these are my input values. I put them in here, and they get multiplied by a negative. And then the result is -3 goes to 2, 0 goes to 1, 1 goes to -2, and 4 goes to 3. So I get the values 3, 2, 0, 1, -1, -2, -4, 3. And I'm going to graph that. 2, 3. Okay, so 1, 2. This is the original f. Okay, and then I'm going to graph the new one with these points. So 3, 2, 0, 1. That stays. -1, -2, and -4, 3. Whoops. Down here, up, then over. Okay, and what happens is this got flipped, but it got flipped over the y-axis. So a flip over the y-axis is going to affect the domain. So my domain went from -3 to 4 to, right here, -4 to 3. So I take my original f of x domain, which was -3 to 4, and I multiply it by a -1 to get -4, 3. So that's my new domain, and my range stays the same. Okay, last one. We're going to look at a horizontal stretch. So g of x equals f of 1/3 x. So I need the 1/3 x column to be minus 3, 0, 1, 4. And so this part stays the same, 2, 1, minus 2, 3. But what does x need to be so that when I divide it by 3, I get 1/3, or I get minus 3. So if I start off with minus 9 times 1/3 is minus 3. 0, of course, stays. If I have 3, then I multiply it by 1/3, I get 1. And here, if I have 12 times 1/3, I get 4. So my points, my new points are minus 9, 2, 0, 1, 3, minus 2, and 12, 3. So what happens is this gets stretched. So my original was 3, minus 3, 2, 0, 1, 1, minus 2, and 4, 3. Boom, boom, boom. Okay. Oops. And now I'm going to graph these points. So 9, there's 4, 5, 6, 7, 8, 9. 3, 1, 2, 3. So it'd be 3 minus 2. 0, 1, got that one. And then 12, way over here, 3. So this got stretched horizontally. So this is a horizontal stretch. And it affects the domain. So my domain was originally minus 3 to 4. I take each one of these. So here, notice that I took the x values and multiplied them by 3 to get the new x value. So minus 3 times 3 gives you 9. 1 times 3 gives you 3, and 4 times 3 gives you 12. So I can come in here and just multiply each end of the domain to get my new domain. So my new domain for f of x is minus 9 to 12. All right, and that is what I wanted to show. So that's how the transformations work. Okay, we move each point accordingly to the rules of the function. All right, so now the next video has to do with describing how the functions change with the transformations.